Hey everyone, our next speaker is Abhay Bhargav. He's the founder of We45, a focused application security company. Abhay is a builder and a breaker of applications. He's a chief architect of Orchestron, a leading application vulnerability correlation and orchestration framework. In addition to his work in application security automation, he has created the Threat Playbook, a unique open source framework that maintains threat modeling as code with application security and automation. I will hand you off to Abhay.
Thank you so much. Thanks so much, and thanks so much for having me. Really appreciate this event that OWASP is putting up for the developer community at large. I'm gonna quickly start sharing my screen. Just give me a second. I'm gonna stop and then start sharing. Again, I think I just need to share my screen from scratch because I have a couple of demos as well. So I just want to make sure that yeah. So my topic today is access control as code. I'm guessing everyone can see my screen, right? Is there any issue with the screen share? Let me know. If there is nothing, I can just continue. So my topic today is access control as code. This is an area that I've been looking into for a while now, probably a few months. In fact, I kind of hit upon this thought process about a year and a half back, but really started diving into this a little bit more recently, perhaps 6 to 7 months now. And I really like the way the industry is headed in terms of these areas. So I wanted to look at this and talk to you about this and look at some of the research that I've been working on in this space. So this is access control as code. I'm going to be talking about a few frameworks and things like that. I do have a couple of demos as well lined up as part of this talk. So I've already been introduced. Just to give you a little bit additional flavor, my name is Abhay. I run We45, which is an AppSec company. We also have AppSec Engineer, which is our online training platform. We're big on training at We45, so we have some very high quality training that we do at places like Black Hat, OWASP, and DEF CON, things like that. And we also have this as part of our online training practice. I do a lot of training. I do a lot of open source. I do a lot of AppSec automation, cloud security, Kubernetes. Generally, if it's something at the cutting edge of AppSec, you'll typically see us working on some of this in that area. Aside from that, we also do a lot of security services like pen testing and things like that. Other than that, I do recommend you check out our YouTube channel. We have a very active YouTube channel. We have a lot of info and demos that we keep putting out there and on my blog as well. And you can also follow me on Twitter and follow We45's work on Twitter as well. Now, I'm going to kind of quickly run through this because 30 minutes is a little short for me to actually do a full presentation, but I'm going to kind of keep this short and keep this sweet. So we're going to be looking at some issues that obviously a lot of us see with APIs and microservices. Today, I'm sure it comes as no surprise to anybody that these are two areas that are pretty big right now, right? A lot of us have a lot of work that we put into microservices, a lot of work that we put into APIs. This has become a very popular way of deploying applications, especially microservices. It's a very popular pattern of deploying applications and running services at scale, especially with the cloud coming into the picture. However, there are some major security issues with this, and we're going to talk about that just a little bit. Then I'm going to be looking at something I call decentralized frameworks, right? These frameworks are essentially security specific or purpose-built frameworks that are meant for security, right? These are frameworks that are meant for security, policy enforcement, and things like that. And it's integrated into a way that APIs are actually consumed or APIs are actually delivered. And this is something that we're going to be looking at as well in the in this presentation. And I'll be looking at OPA, which is Open Policy Agent, and another framework called CASBIN for the whole access control as code piece, right? So that's basically what I'm going to be doing. So let's talk a little bit about API security flaws. Now, OWASP has an API security top 10, which is a very powerful project. It's actually a very good project because you kind of get to understand that the OWASP top 10 and the OWASP API security top 10 are not exactly the same thing, even though APIs are web apps in many ways. They're not the same as every web app, right? So for instance, cross-site scripting and things like that are not so much of an issue with APIs, whereas APIs, you largely come across things like BOLA, which is broken level, object level authorization, or excessive data exposure, or function level authorization, or broken authentication. Most of these are access control flaws or information disclosure related flaws. Now, these are the kind of flaws that you'll typically see with APIs. And we've seen a ton of these in the real world, right? In recent events, and I've taken these news snippets from the last 3 months itself, and you'll see that we've had these from John Deere, we've had Echelon and Piloton. All of these services have had leaky APIs where I've been able to do an insecure direct object reference where I can do an increment of 1001 or 1002 and gain access to somebody else's data, or I can just query a user's email and gain access to their data set which has been processed by the API without any kind of authentication or something like that. So you are typically looking at a world in which API security has largely been a factor of access control flaws being the kind of the leading cause of most of these API security flaws, right? So most of them have access control flaws either related to object access control or functional access control or authentication in a large scope itself. And a lot of this is understandable simply because in the API world, it's hard, right? You're rolling out, especially with the way we deliver applications and microservices today. It's kind of hard because you have so many different services that are being deployed on the cloud or deployed on Kubernetes or what have you. And when they are getting deployed at such scale, there's a good chance that one service is probably not as secure in terms of its access control parameters, or you've not rolled out access control parameters perfectly, or you've not implemented authorization very well, or there may be an inconsistent implementation of access control at some point in time. So you might have these issues kind of becoming these are very common. You see this a lot with APIs. At the same time, when you look at APIs today, you'll see that they've been rolled out more than ever, right? With the rise of containers, again, APIs and microservices have become the popular deployment method. You also see the rise of gateways, right? So you also see API gateways. In fact, I think one of the earlier talks today was around an API gateway called the OWASP API gateway, which is very nice to see because API gateways are big. You have tons of API gateways like your AWS, your Azure, your Google's, and aside from that, you also have your Kong API gateway, you have Traffic, you have Nginx, you have a ton of these that are operating in the cloud native space. So you have containers, you have API gateways, you have containers deployed in places like Kubernetes, or you have serverless functions as a service, which again uses API gateways in the back, in the front. So API gateways and containers have kind of made this ubiquity of microservices, so to speak, right? Microservices is not really some sort of a very fuzzy deployment pattern. It becomes very, very mainstream with these technologies coming into the picture. And at the same time, on the one hand, you have all of this incredible development happening. On the other hand, you also have these a riddling of access control flaws that happen against API. So this is a very common scene that I'm sure a lot of you have heard of. So the idea here is that you have a ton of APIs and you have a ton of different teams working on different APIs and different services. And obviously, each of these APIs, you have obviously a business logic, which your service, whatever your microservice is, that service has its own business logic. But on top of that business logic, each service needs to have authorization, needs to have input validation, needs to have object access control, needs to have authentication, needs to have logging, needs to have all of these things. Now, if this needs to be done at scale, there's a good chance that some of these may get missed, right? At least in some service, you might have something that gets missed, or some other service, some other thing may get missed. And this is the kind of thing that happens. And remember, these are not services that you just deploy once and only change it 6 months later. These are services being deployed rapidly. The reason you move to microservices is because you want rapid deployment. You probably change them, or you probably deploy multiple times a day for a lot of these services. So at any given point in time, we could introduce security vulnerabilities just because we are dealing with that kind of scale and there is inconsistency in the air because of that. Right. So the idea here is that the idea is not to push more security onto these services, is to essentially push less security. And this is something that I'm sure a lot of you will find like WTF, right? What's happening here? Why do you mean less security? Shouldn't there be more security? The point here that I'm saying is that why not have decoupled security, right? Not less security, but decoupled security. Instead of the APIs having security hard coded or inbuilt into the API logic, why not run security as a separate service entirely? right? Why not run security as a separate service entirely that integrates with the API gateway and not with the APIs themselves, right? So the gateway becomes, since everything comes through the gateway becomes the single point of validation, not only a single point of access or control, right? So the gateway becomes a single point of validation where every single request coming in is validated against a set of rules or against a set of policies, and only based on whether those policies are met or not, we essentially go ahead and we allow that request to go in. So input validation, policy controls, access control, object level access control, function level access control, all of these things are handed off at the API gateway and not happening in the API, right? So you're not hard coding any API rule simply because APIs, you want to make sure that they're business logic only. Everything else is done outside of it. So you're decoupling security from the API gateway. And that's really the point that I'm going for. So the idea here is to leverage as code platforms, or platforms that allow you to define all these policies and rules as code, so that you can actually go ahead and do this in a very comprehensive way. So that's really what we're trying to do. So the needs and motivations, obviously, they're part of a larger set of offerings. Rapid release, these things are changing, and you need to have security being decoupled because you want security to be effective and not hard coded as part of it, where you could have 100 different or 1,000 different inconsistencies when you're dealing with these APIs and microservices. So this is basically what you have. You have a bunch of different capabilities that you can do, but the idea here is to not hard code, but to essentially have these decoupled, right? So you have a lot of different ways you can do this. Some of these are in the container, in the runtime part of it. Some of these can be done at the API gateway. Some of these can be done as part of log collection and things like that. But the idea here, at least today's talk, I'm going to focus in on this, right? I'm going to focus in on the API gateway side of the fence and the kind of security controls you can put. So I'm not going to focus so much on the runtime container bit. I'm just going to focus in on the API gateway and the kind of access control models that you can set up inside the API gateway or integrated with the API gateway, so that the API gateway becomes a pretty big source of security validation and not not the APIs themselves. So the API gateway today, the modern API gateway can integrate with a bunch of different services. It can integrate with your identity provider. It can integrate with your policy as code service. It can integrate with a bunch of things. And that's really what we want to leverage. Now, one of the policy frameworks that I'm going to be talking about today is the Open Policy Agent. Now, I'm sure some of you have heard of the Open Policy Agent, some of you have not. Now, the Open Policy Agent is a really powerful framework that allows you to define policies and roll them out on your API gateway, or roll them out anywhere. You can even roll them out on an operating system. It's literally, you can roll them out on different use cases. It's agnostic in terms of how it can be deployed. It's just that it gives you a framework where you can author policies and it will enforce the policy based on the kind of inputs that are coming in. So the idea of Open Policy Agent is that you get a request coming into your API gateway. So in this case, I call that the service, and the service forwards the request to the API, to the Open Policy Agent. For simplicity, I'm just going to call it OPA, right? Now, OPA receives the request from your API gateway, and you have all your policy rules and security rules loaded in OPA. And what OPA does at this point is essentially go through the input or request that comes in, checks it against all the rules that are applicable, and then comes back with a accept or deny decision, right? So basically goes back with a accept or deny decision that says, hey, look, this has complied with all the rules. Go ahead, allow it if you want. Or it could say this is not complied with all the rules, so you should definitely deny it, right? So OPA essentially validates it, or does all the policy decision making, and then sends it back to the service, which will take a decision on whether you should allow it or not. It comes back with a simple allow or don't allow, right? True or false, allow or don't allow. So that's what OPA is. And OPA is JSON aware. So everything breaks down into a JSON object or a JSON array, or a JSON object, and basically OPA validates it against this JSON object, and that's what it does. So it's extremely versatile because you can use it anywhere, right? You can use it for APIs, you can use it for Kubernetes, you can use it for OS policy management, you can use it for a ton of different things. So this is a simple example of OPA for an API, right? So it will check whether the input path is /users and the input method is an HTTP post, or if the input path is /users or profile ID and the input method is get or whatever it is. So you can actually write All you can not only do path validation, but you can also do input validation. You can do user validation. You can do JWT authorization. You can do all of that good stuff just with OPA, right? So that's one of the huge benefits of using OPA. Right. Now, what I'm going to do is I'm going to quickly show you a demo of OPA, and I'm also going to explain some of the use cases of OPA as well. So, so let's just quickly get into one of the deployments that I'm going to do. So I have an API here, and I'm going to, I've already deployed it on my Kubernetes cluster. So if you see my Kubernetes cluster, you will see that I'm running a bunch of, one second. So you'll see that I'm running a bunch of services. You'll see that kubectl get pods. You'll see that I'm running a bunch of services. I'm also running, as you can see here, I'm running a bunch of services. Now, this has been deployed. It's accessible externally. It has all of those things. Now, I'm going to go over my OPA rules to just talk about what it's doing. So what this rule set is doing is that I have a URL called /people, and I also have a URL which allows a get request, and I also have a post request and things like that. I have all of these different rules. Now, based on these rules, my APIs don't have any security hard coded, right? The APIs don't have any kind of security hard coded. It's essentially going to take the JWT token, whatever token I send it, it's going to take that particular token and ensure that it is, first of all, the token is valid, the signature of that token is valid, then it will make sure that the token has not expired, then it will make sure that the token is, whether there is a get request. So all of this is being done at the API gateway level. So I'm using an API gateway called Envoy, which is a very popular HTTP proxy. I'm using that as an API gateway. So you'll see that I'm using Envoy as the API gateway, and you'll see that I have essentially loaded up my OPA rules to validate a bunch of different things. So first of all, is the token valid? Is it a get request? Is it a guest person who's accessing this? What is the kind of action which is allowed or not allowed? So you'll see that if I'm trying to access /people, it'll check whether it's a guest or whether it's an admin, whether the post is an admin user or not. So I have two users in this case. One is Alice and one is Bob. Alice is a guest. Alice can only get things, you can only see things, but Alice cannot create a user, right? But Bob is not only a guest, but Bob is also an admin. So Bob can see users as well as create users, right? So that's basically what Bob can do. But Bob cannot create a user with Bob's first name. So if Bob tries to create a user with his own first name, that won't work. So that's basically our rule set. And this is deployed not inside the API, this is deployed on the gateway. And all of the validation happens in the gateway. It doesn't happen anywhere else, right? Everything happens in the gateway. So I have already configured a bunch of services. Let me just access these services. So I have some services that I've already deployed. I've already deployed these bunch of services. Now let's try and access this service without any kind of token or without it. So this is not only just going to check the user and all of that, it's also going to validate the JWT, right? It's not only just user validation, it's also going to validate the token, check the signature. So OPA has a extremely versatile framework that can handle all of this stuff. So what I'm going to do first is I am going to not send any kind of token, right? I'm just going to try and access this without any token. So I'm going to remove the authorization header. And I'm going to try and access this service, and you'll clearly see that it's a forbidden thing. Now, this is entirely happening on the API gateway. It's not even hitting the APIs. It's not hitting the actual API in question at all. Now I'm going to try and access it with Alice's token, and I should be allowed because Alice is a guest user, and Alice should be allowed to get users. And when she does, Alice clearly gets a response that says, "Hey, this is blah 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 blah." You get some information about John and Jane Doe. Now, if Alice tries to create a user, that's when Alice completely gets stonewalled because Alice cannot create users. Not allowed. You'll see that our rules essentially says that, hey, you know what? Guests can't create users. Only admins can create users. Now, Bob is an admin, right? Now, how do we know Bob is an admin? Because clearly his token, I think, has some kind of a access privilege that Bob is an admin. So if I look at jwt.io and look at Bob's token, you'll see I think I should see a rule set that says Bob here is an admin, right? So Bob's an admin. That's pretty straightforward. Now, if we see what Bob tries to do, Bob is of course going to get users, but Bob should be able to do that quite easily. Now, Bob's going to try and add a user, and Bob should be able to do that. So you see, I'm pasting Bob's token, and that works. Created. Now, if I go and get people, oh, sorry, not get people even with Alice's token, you'll see that our new Charlie user has been added. But if Bob tries to add a name with Bob's own first name, let's say Bob tries to add a user with first name Bob, then we should see that it's forbidden. Now, this is really cool because all of this is happening in the entirely as part of the API gateway, because OPA's policies are being enforced on the gateway and nowhere else, right? It's really powerful stuff. Now, this is something that is great simply because I don't have to sit and hard code any of my security rules. I don't have to hard code any of my policy rules inside my APIs and have inconsistencies as a result. All I have to do is literally just write my rule set, and I can even write unit tests for that rules. It essentially becomes codified, right? My entire access control model becomes codified. So that's really powerful stuff, and that's something that I really love about OPA. And you can do this you can extend it across a bunch of things. In fact, I've created very, very advanced, very, very complicated use cases with OPA, with object access control, with functional access control, with Kubernetes, with literally anything, right? You can use it wherever you can find some use case where you have hierarchical data sets like YAML or JSON, which is literally everywhere, especially JSON. You should be able to use OPA for validation, for policy enforcement, things like that. It's really amazing stuff. Now, I'm going to be going through our second framework, which I really like, which is Casbin. I'm not sure how many of you have heard of Casbin. So Casbin is a very popular, but I'm not sure whether it's as popular in the AppSec community, but I've seen that the developers, a lot of developers use Casbin, a lot of developers contribute to Casbin. I've not seen this spoken of in the AppSec community, which is kind of weird because this is entirely all about access control. Now, Casbin is essentially an object level access control framework. You can literally use this to write object level access control, right? So you can so what happens with Casbin is that you have different types of access control models. You can say ACL, or you can use RBAC, or you can use ABAC, or role based or attribute based, or whatever different types of access control models, and you can start templatizing your entire access control model. One of the biggest challenges with authorization is the access control model, right? Because you have to design it, and sometimes when you design it, you would have made a mistake, and when you're trying to roll out, it's becoming a problem. So Casbin gives you all of that in this nice little domain-specific language, which it calls the access control model. So this is the access control model. So if you see what happens here, the access control model essentially goes by the request, which is coming in from the user, and the policy, which is something that you have created. So the request is coming in from the user, the policy is something you've created, and you can create a matcher that says, hey, request, so the request has a subject object action, the policy has a subject object action. Now, if the subject matches subject, object matches object, action matches action from both request and policy, you have a match. And if it matches, you are allowed. If it does not match, you're not allowed. It's really that simple. So it breaks it down into very simple understanding. You can break down your entire access control model into a very powerful and very easy to represent model. And you can use this with multiple types. You have role-based access control where you can use groups and roles and things like that. You can do tenants and domains. You can literally extend this to quite a bit, right? So you can have group definitions, you can have role definitions, you have domain. So instead of subject object action, you can have subject domain object action. So if you have multi-tenant systems with a domain and things like that, you can even define access control models for that. And you have to store the policy in either a file or a database or wherever you want, and it'll essentially match the request coming in to the policy based on the model that you've defined, and you're good to go, right? That's basically what Casbin is, and it's really powerful stuff. Now, one of the things that I recently worked on was a project where, now obviously open policy agent is really powerful, but you have to hard code everything. But if you want a dynamic object access control system, that's where Casbin comes in, where you can essentially load everything within Casbin, and you can have OPA talk to Casbin and do the granular access control pattern and come back with a true false kind of a response. That's really powerful what you can do with Casbin as well. Again, I'm not going to be able to give you the entire shebang on Casbin or OPA simply because I don't have much time, but I just have time to show you one more demo. Just give me a second while I get to that. I'm guessing everybody can see my screen. I know somebody was not able to see the code properly. I hope this time you should be able to. Just give me a second while I pull up my project. With this is my project, and let's look at my example. So this let me walk you through the use cases in this example. The use case in this example is that I am running a CRM system, right? So in the CRM system, I am going to sign up as a user, and I'm going to create a credit card. Now, as soon as I create the credit card, except myself and the root user of the system, nobody should be able to access that credit card. Okay, so that's basically the way I've written it, right? Nobody should be able to access that credit card. That's basically the use case. And I'm using Casbin to enforce it dynamically. So every time a credit card is created, Casbin is going to create a policy. It's going to store a policy definition in my database. And in this case, open policy agent is essentially going to enforce it, right? So let's look at some of the code that I have here, and I'm hoping people can see the code a little bit better this time. So I have a bunch of different URLs. So I'm checking out whether the sign up happens with the post request, login happens with the post request. These are all basic things. But once I want authenticated paths, I want to check whether the create customer is happening with a post request, but also is validated with a JWT. So every time somebody accesses this create customer, they need to have a token which is validated from a signature perspective. That token needs to also have a claim called the user claim. So if that user claim is set, only then I allow access to that particular URL. Now, when it comes to the get card, right, this is the one that I really want to protect because it's credit card information. So aside from the fact that I want all these things, which are pretty standard, I also want to query my Casbin service, check whether the user has access to read the credit card. And if this comes back with a 200 status code, I go ahead. Otherwise, I don't go ahead. Right? I am not allowed to respond. I just throw a 403, denied. Right? I don't allow the user to access it. So I have written out all these rules, and OPA is going to enforce it right at the gateway. So I'm going to just run this at the gateway, and we should. I think we just should have a couple of minutes to Docker compose up. Hopefully this should run just with enough time for me to spare to. Okay, just give me a second while this is nearly done. Okay, I think it should work. Now let's try and Docker PS. I have my services running. I have a bunch of services running. My API gateway that I'm using is called Traffic, not Envoy. I used Envoy in the previous example, but in this case, I'm using Traffic. So that's basically what I'm doing. So let's make an HTTP post to and sign up as the user. I'm going to sign up as the user hello, and I'm going to set the password hello, right? I'm going to sign up as the, oops, I wonder what happened. Sorry, folks, just give me a second. I'm sorry if this, I don't know why this didn't work. I think there may have been some existing volumes with data. So I'm going to check Docker. This is the problem with live demos as always. Docker volume prune, making sure that all the volumes are gone. I think that was the issue. Docker network prune. Yes. Okay. Docker compose up. Yeah, sometimes this happens when you're running a local instance. So hopefully that should not be a problem from now on. Yeah, I think it's okay now. So I'm going to sign up a user. Yeah, user signed up successfully. I'm going to log in as that user. I'm going to log in as that user. Now, once I log in as that user, I'm going to get a token. I'm going to export the value here and load that JWT. JQ dot. So I should have my token value. I've logged in. You can see that my token value is here. Now I'm going to create a card, HTTP post. Now, as soon as I create a card, you will see that that card is automatically mine, right? So only I can access it. So I've created the card, and when I try to get the card, which is HTTP get with my token, I'm going to access as myself with my token, and I get the card. I get my credit card, which is normal. But now let's say I log in I sign up and log in as another user. I'm going to sign up as another user, in this case hello2, and I'm going to log in as that user. So let's do that. And I'm just going to change the value here. This is another user's token, hello2, hello2. Now I'm going to try and get the card as that other user. That previous user's credit card, I'm going to try and access it as another user. And you'll see that my API gateway automatically shuts this down. Right? It does not allow this simply because it's not in my CASBIN access control policy. So OPA is chained with the CASBIN access control policy to enforce this. And only if it gets a 200 status code will it allow me to access my credit card. Otherwise, it just won't. So you can actually set up very granular access control parameters with things like this and make sure that it is, you can scale with much higher success with your APIs. You can enforce it across a bunch of APIs, or you can enforce it across multiple pools in different ways. You can write unit tests, and it really extends the capability of your access control as code. That's basically the point of this talk. That's it. I'm done with the talk. If we do have some questions, I'll be happy to take them. I know it was a little quick, but
Abhay, that was amazing. I have so much homework to do now. I don't see any questions in the chat, and as always, you can find Abhay on our Slack channel,
yeah,
and ask him any questions that you like. Abhay, thank you so much for your time and going through this. This was amazing. And once again, I want to thank our platinum sponsor, SNCC, for sponsoring us and for supporting this channel. We definitely couldn't do this without them today. And we'll see you on the following show.